Welcome! In this session, we will estimate the confusion matrix for our neural network model and compare it with the one that we estimated for the logistic regression. Well, we are here in R, and to make a consistent comparison, we will do the confusion matrix for our neural network model with a cutoff threshold of 0.5, and that is without taking into account the error cost. So let's create first a vector of ones with 5,781 observations. So we will create the variable classification model, not model 2, but model 1, because this is the one for the neural networks. And we will create a vector of 5,781 observations. So we will use the function rep for repetition. We will repeat the number 1 for 571.81 observations without the comma, sorry. I press enter and I created this vector of ones. Now I will assign the zeros to this vector of ones, so I will do the actual classification. So for this classification model 1, I will take those observations which have a prediction defaulter less than 0.5. So the probability of default of this, according to our model, or neural network model, has to be less than 0.5. And for those observations, I will assign a 0. I press enter, and I have created the classification for our neural network model. If you want, we can look at it. And that's our classifications. The ones that have a 1, I'm saying these are going to be default because they have a probability higher than 0.5. Now I'm going to convert this variable to a factor because that's a requirement of the confusion matrix function. I have to have two factors with the same levels. In this case, in this specific case, they have to have two levels, 0 and 1. So I'm going to convert classification model to a factor. So I use the function as.factor and I write again the name of the variable classification 1. So now it's not a character but a factor with two levels. And now I'm ready to use the function confusion matrix of the package caret. Then I'm going to write three parameters. The first of them will be the classification of the neural network model. The second parameter will be the real observations in the variable testing defaulter flag. So I'm going to convert it to a factor to be completely safe. Then I'm going to compare factor with factors and I'm not going to have any problem. I write testing, the sign of dollar, and then the name of the dependent variable. And the third parameter is positive equal 1. So I'm telling R the ones that have a 1 are the ones that are positive, are the true values. Are the positive, sorry, they are not true. As we can see, the neural network model with only one layer and two neurons is slightly better than the logistic regression model, as it has a slightly higher accuracy of 0.7336 compared to the accuracy of the logistic model that was 0.7327. Also, we can see that the neural network model has a higher sensitivity than specificity. You can see that this model has a sensitivity of 0.90 and a specificity of 0.30. And that means that this model makes a better job predicting positive values than negative ones. So you can see that it has more or less errors predicting the true positives than by predicting the true negatives. And that was the same for the logistic regression model. It had a higher sensitivity than specificity. Now you can construct neural network models, make predictions, estimate confusion matrices, and compare the accuracy of the models. And it is time to have fun by building your own neural network models, and that's what you are going to do in the next assignments. Thanks for watching.